This is the solution for the question on page 491 of Text and Test 4. It's question 29. And it says that given 2 log to the base 2 of x equals y and log to the base 2 of 2x equals y plus 4, find x. Well, first of all, I'm just going to investigate each of these original statements that I'm given separately and see what I can come up with from them. Again, I'm going to be referring to my rules of logs. Have the rules of logs open next to you, please, from your log tables. And again, as always, you can pause the video, attempt the question, and then play and check if you're correct. Okay, so I'm having a look, first of all, at 2 log to the base 2x equals y. Right, okay, so I'm going to do a bit of rearranging with this, and the rule that I'm going to use is rule 3. So this rule allows me to take my coefficient of 2 here and bring it in to my log and turn it into a power. So I'm going to rewrite the statement as log to the base 2 x squared equals y. And the reason that I've done this is that now that the log doesn't have the 2 in front cluttering it up, I can just write this as an exponential equation. So I can say 2 to the power of y equals x squared. It doesn't appear at this stage that I can do very much more with that, so I'm going to park that for a moment and look at my second statement. So I have just one log term on the left-hand side, and I'm going to be able to, again, take what I have here and write it as an exponential equation. Now just watch out, all of this stuff on the right-hand side, the y plus 4, is going to become part of the exponent in that case. So how is that going to look? So here I've got 2 to the power of y plus 4 equals 2x. Okay, I notice here that I've got addition in my exponent. So I know that I can split this up and I can write it as 2 to the power of y multiplied by 2 to the power of 4. This is looking promising now because I can see that in both of my equations I've got this 2 to the power of y. So this gives me hope that I might be able to use one to develop the other. Okay, I want to stick with this one over here for a moment. So I can obviously evaluate 2 to the power of 4 and write it as 16. Just take care as you're going down through this to keep this as 2x. It's not 2 to the power of x. Don't accidentally write that. Okay, if I can maybe get this as 2 to the power of y equals to something, that might be useful over in conjunction with this statement over here. So I'm going to write 2 to the power of y equals 2x over 16. Okay, so now I've got the same statement, or the same beginning to my statement here and here. So I'm going to be able to equate x squared and 2x over 16. Okay, so I've got x squared now equals 2x over 16, and I'm going to want to try and solve this out if I can. So the obvious thing to do first of all is bring the 16 up in front here and multiply. And again, at this point, a good idea would be to pause the video, try and solve this out yourself and see how you do. Okay, it's turning into a quadratic, so I'm going to want to get it equal to 0. I'll bring my 2x across and subtract. And now at this point, I want to solve. So how can I solve? Well, I can solve by factorising out the common term, which in this case is x. And now I can get two solutions, which are x equals 0 and x equals 1/8. I'm not just going to take it on face value now that both of these work. And I would just point out, looking back to the question, it says find the value of x. It doesn't say plural values. So I kind of have a bit of a hint from that I probably only have one solution. So I'm just going to check and see what's going on there with my x equals 0 and my x equals 1/8. At first glance, looking back to my original log statements, there doesn't appear to be a problem with 0. So, okay, I could put 0 in here and I could put 0 in here and I wouldn't get a negative. And I could put 1/8 in here, and I could put 1/8 in here, and I wouldn't get a negative. But let's look a little bit further down our question, just to see if we run into any difficulty. And I'm thinking particularly about these two statements here. Okay, so let's check our x equals 0. And let's just check if the 2 to the power of y equals x squared. So I've now got 2 to the power of y equals 0 squared. Okay, well, what am I going to get for 0 squared? Well, that's going to give me a result of 0. Is it possible to put 2 to a power and get a result of 0? It's not, and it's for pretty much the same reason that I can't put a positive number to a power and get a negative result. If I've got a positive number and I put it to a power, what I'm effectively doing is I am using the 2 repeatedly in some way by multiplication or potentially division if it's roots that I'm talking about to get a result. And no matter how many times, just to take the simple version of it, no matter how many times I multiply 2 by itself, no matter what y is, I can't get a result of 0. So this statement is clearly false. And so that means that I must disregard this x equals 0 solution. Since I'm checking, I'm just going to be absolutely certain about x equals 1/8. Now, it's unlikely that I'd have to cancel off my second result, but let's just be careful. So looking at the same statement, first of all, 2 to the power of y equals x squared. So 2 to the power of y equals 1/8 squared. Spend a bit of time just investigating if this is possible. Is it possible to have a power of y that will give me this result? Well, 1/8 squared is 1/64, which I can also write as 2 to the power of -5. So there isn't a problem with that. It is possible to put a power on 2 and get 1/64 as a result, and that power will be -5. So far 1/8 is fine. Now let's check it for the second statement here. So I'm just subbing 1/8 in for x, and 2 times 1/8 over 1/16 gives a result of 4. Now clearly there's a power, y, that I can put on 2 to get a result of 4. If I square the 2, I get 4, so it's possible to have a y value of 2 to get this particular result. So there's no obstruction to 1/8 being 1/8, I should say, being my value for x. So x equals 1/8 is my solution for this question.